Good morning, afternoon, and evening, wherever you are in part of the world. We are attending the session. Welcome to this presentation on NVIDIA's exciting chip roadmap, which outlined the company's ambitious plan to drive AI innovation. This also helps you, if you are an investor, to understand how the NVIDIA strategy and also what is their technological advantages and also some of the approaches or strategies they identify over the competition to how it helped them to get the top of the margin as well as keeping up with the technology innovation compared to the other vendors. So one of the key uh, the strategical approach NVIDIA does is the one year, the year called 1 year rhythm. It's actually they have a roadmap for clear of what is there coming into a 1 year roadmap. So they adopted a consistent 1 year rhythm for releasing new generation of chips, ensuring a steady stream of advancement in both in the technology as well as from a performance scale, etc. This approach allows for continuous innovation and rapid adoption of cutting edge technologies. So NVIDIA announced its Hopper architecture at the GTC 2022 event on March 22nd, 2022. The Hopper architecture is specifically designed for AI and high-performance computing workload. This architecture introduced a significant leap forward in GPU performance, which with its innovative feature and capabilities, Hopper is designed to handle most demanding AI workload. The first H100 GPU based on the Hopper architecture was released in Q3 of 2022. NVIDIA announced the Grace CPU superchip during the GTC 2022 as well. This CPU is designed for AI, HPC computing hyperscale cloud application and featuring 144 core in an ARM architecture with 1 terabyte of memory bandwidth. This Grace CPU is intended to provide an exceptional performance for demanding computational tasks, particularly those r- uh, reliant on high memory bandwidth and large data set. So the Hopper architecture, which was introduced in 2022, with the GPU architecture H100 GPU with 80 billion transistors built on TSMC 4 nanometer processor, and the Grace CPU superchips announcement of 144 core architecture with the Neoverse core and the NVLink chip-to-chip interconnect and 1 terabyte of memory bandwidth. So the NVIDIA's announcement of the Grace CPU superchip during the GTC 22, the CPU is designed for AI, HPC high performance and hyperscale cloud computing application featuring 144 cores and offering 1 terabyte of memory bandwidth. This Grace CPU is intended to provide exceptional performance for demanding computational tasks. So the NVIDIA's Grace CPU superchip began shipping to customers early 2023 as announced during the Computex 22 announcement. It is designed to power a wide range of high performance computing, HPC, and AI hyperscale cloud application, providing significant improvements in energy efficiency and memory bandwidth. So in 2023, they have a bunch of product. The one is actually the shipping of Grace CPU, and also the advance announcing the H200, which is actually the next version of H100, and Grace Hopper super chip. So let's go one by one. So the Grace uh, this chip, which was their first CPU. So they identified early on that in order to build a large, increase the number of performance and to capacity for large workload and HPC system, it's not possible to increase the number of transistor pack in a single GPU. So the best approach is to have a combination of CPU plus GPU and building a system. So that's approach. The first they started with a third party chip from AMD and also the Hopper CPU from NVIDIA. But with the introduction of the Grace, they are able to announce the first super chip built with the Grace Hopper. where we have the Grace as the CPU and um, Hopper as GPU, which is announced in the August 8 of 2023 SIGGRAPH. This super chip combined NVIDIA Hopper GPU architecture with its Grace CPU featuring HBM3 memory for exceptional performance in AI and a high performance workload. This first system based on the Grace Hopper super chip are expected to be shipping in the 2024. So the next one is the H2100, which is actually the upgraded version of H100. The range of this computational capabilities of increase under the hood of H100. H100 shared memory of this networking with a higher networking configuration and architecture. The key difference comes from the massive increase in VRAM with the 121 GB of HBM3 memory, offering a substantial upgrade to H100 HGB HPM3. The H200 capable of 43% higher GPU memory bandwidth than the H100 with a peak of 4.8 terabytes bandwidth per second and 900 Gbps of point-to-point connection bandwidth. The 2024 is redefining the ecosystem with the Grey Hopper super chip, the enhanced integration of JCPU and Hopper GPU, which started shipping in um, uh, early 2024. So this include the H200 GPU, which started shipping in Oleum in Q3 2024, featuring 121 GB of memory with HBM3 with 4 terabytes bandwidth. So the available this was originally announced in 2023, as we shared previously in SIGGRAM in uh, so this one actually enhanced the almost the 50% faster than the current HPMD memory, as well as the 124 ARM Neo versus cores of the GPU CPU from the Grace CPU, so which kind of build in, and then also we have an NVLink chip-to-chip interconnect of up to 900 Gbps total bandwidth, seven times higher than the PCI Gen 5 configuration. And also we have the dual configuration with the 1.8 terabyte of fast memory can be connected with additional super chip using NVLink. Performance dual configuration deliver up to 3.5x more memory capacity and 3x more bandwidth than previous generation of up to 10 terabit per second of combined bandwidth with this combination. So so this actually enhanced their uh, both reduce the time for training the largest model with the super chip or system approach. This was one of the key uh, leap forward in building this HPC and AI system. Now at GTC 2024, NVIDIA unveiled its next generation chip, which is the Blackwell GPU architecture, making a significant leap in AI and high performance computing. The star of the show was the B200 GPU, uh, boasting a 208 billion transistors and offering up to 20 petaflops of performance. This chip designed to be deliver substantial improvement in AI training and inference. NVIDIA also introduced the GB200 super chip, which is the combined two B200 GPU with the Grace ARM CPU. This powerhouse offers 30 times the performance of the large language model inference computing into its predecessor, while potentially reducing the energy consumption by up to 20 times. 25 times. The company showcased the DGX GB200, a liquid cooled system built around the GB200 super chip. Eight of this system form a DGS pod cluster delivering an outstanding 11.5 exaple of computing power. Perhaps the most impressive announcement was the GB200 NVL72, a rack scale system designed for the most demanding AI workload. It houses 36 GB200 Grace Blackwell super chip, effectively creating a single GPU with 1.4 exaple of AI performance and 30 terabits of fast memory. So NVIDIA emphasized the efficiency gain of the Blackwell architecture, stating that the task that previously required 8,000 Hoppers GPU could now be accomplished with the 2000 Blackwell GPUs, significantly reduce the power consumption. The company also has announced that perhaps with the major cloud providers like AWS, Google Cloud, and Microsoft Azure, who plan to offer the Blackwell-based instant in their services by late 2024 or early 25. In October 2024, this NVIDIA announcement, the shipment of the GB200 NVL 36, which is the 36 Blackwell GPUs, also GB200 NVL 72 with the 72 GPU. So initial recipient is Microsoft, expect to receive one of the largest allocation, and also AWS and Meta, Oracle. So the exact number of machines to be shipped in December is unknown, but this is shipped to the cloud vendor. So initial production will be take place in Taiwan from Foxconn, and also Quantra are the primary integrator for the first Blackwell based servers. So now come to the announcement of the Blackwell Ultra GPU, which is actually in expected in 2025 production. So this is a position as the intermediate update between the current Blackwell architecture and upcoming Rubin, which is expected as the next version. It is likely to be an enhanced version of the existing Blackwell GPU, potentially offering improved performance, mainly is on the it's going to be used HPM 3E memory, higher memory or bandwidth capacity, which is expected to be available sometime in 2025. June 2, 2024, at the Computex in Taipei, NVIDIA CEO Jensen Huang unveiled the Rubin as the successor of the Blackwell GPU. So the Rubin is named after the late U.S. astronomer Vera Rubin. The expected availability is of first half of 2026. So the family's GPU family labeled as R100 GPUs, a new, and also there is a CPU announced which is called Vera. Memory will transition from HPM3 to the next generation of HPM4, and then also the fabrication is 3 nanometer process technology at Samyani Semiconductor Manufacturing, and the design is 4x reticule design, large surface area on silicon wafer compared to the Blackwell. So and then it also there is another announcement I think we'll cover in the next slide. So now come to the final slide where we have the next version of the roadmap is actually Rubin Ultra, which is actually a 125 HTM4 higher bandwidth memory bandwidth capacity. So that will be expected to ship in 2027 with the added performance from original Rubin. So hope you got the full roadmap for NVIDIA till 2027 with detail on each of the architecture as well as so if you need to build any of your understanding of your system to you can plan accordingly as for this the the, the architecture coming on shipment and based on what is available today and what is shipping and what is expected to ship. So this one of the benefit is that you have a clear roadmap as well as kind of a shipment date, so you can plan your system design as well as your infrastructure design as well as your planning budget, etc., in a very systematic manner. Hope you have got this presentation help you understand the NVIDIA's approach of the chip advancement to support the next generation HPC and AI systems.